we're solving max consecutive ones free, which we're going to try and do with minimum complexities shown here, O(n) in time and O1 in space. Our problem statement is short and sweet. We're given a binary array called nums and an integer k, and we need to find the maximum number of consecutive ones in the array, considering that we can flip at most k zeros. Your options for an optimal solution here are A, 2 pointers, B, hash table, C, sliding window, or D, Floyd's tortoise and hare. I'm going to pause for a couple of seconds while you think about the best method. So, for those of you who recognize the most optimal solution, congratulations. And for those of you who just want to see some code, the answer here is C, sliding window. Let's look at a brute force approach. So, as given by our hint button, one brute force approach would be to try all possible subarrays of our given array and keep track of the maximum number of consecutive ones that can be obtained by flipping at most k zeros. I'm not going to read through the algorithm listed at 1 to 4, but suffice to say, the time complexity of this would be at least O(n) squared and more likely O(n) cubed. Obviously, that's far from optimal for this problem. Looking at our optimized approach, the solution would utilize the sliding window technique, maintaining 2 pointers, start and end, to define our current subarray. That's all within that for loop in line 6. Additionally, we keep track of the number of zeros within the subarray. What our solution eventually does is simply find the longest subarray with at most k zeros by incrementing zeros. However, I'm going to go through this in a bit more detail line by line. First of all, we've got this sz variable, which calculates the size of the vector nums, storing it like so. Result is initialized to 0, and it stores the maximum length of consecutive ones. After that, we've got our key line, which is our for loop. This essentially iterates over the array, and we're using the end pointer to do so. We initialize the start pointer and zeros counter to 0 as well. And the loop continues until end reaches the end of the array. This line increments zeros if the current element, nums end, is equal to 0. After that, we've got this while loop. While zeros is greater than k, zeros minus equals num start plus plus equals 0. What does that mean? Well, the while loop adjusts the start pointer and decreases the zeros counter until zeros becomes less than or equal to k, if necessary. It moves the start pointer forward and subtracts 1 from zeros if the element at num's start is equal to 0. This ensures we have at most k zeros. After that, we've got this maximization of result, so we update the result by taking the maximum of the current result value and end minus start plus 1. Finally, our function will be able to return the result, the maximum length of consecutive ones, which is stored in this variable. I hope that that's helped, and that's one more problem solving session done with Coding Card Sharp. For a bit more of a challenge, I'm going to provide you with the question and answers one more time. So you've got the 4 options for max consecutive ones, part 3. And if you've watched the video, you'll know sliding window is the correct answer. In this case, the explanation should be quite clear. And the wrong answers also have their own explanations, explaining why they're either incorrect or suboptimal. We've also provided you with some code in Python and Java, if you prefer those languages. And finally, to round off, if you've any questions or any problems with the solution that we provided, it was taken from this Udemy course, and it's provided in the course description below the video, and I would strongly recommend taking this course. Dr. Ibrahim offers a better and more visual explanation than the one that I've shown in this YouTube app, which is just to support the application coding card sharp. In any case, thanks very much for watching, and I hope that this helps you in a future interview.